absolute and relative configuration. You know that absolute means fixed. So you should know about the fixed configuration of the absolute configuration. You should know about the specific rotation, the sign of the specific rotation of the configuration. You should know about the R or S configuration of that compound. In this context, relative configuration is not known to you. It is in relation. If you given any compound, you can determine the configuration with respect to other compounds. So there should be a relation between them so that you can determine one compound or configuration with respect to another compound by knowing the configuration of that another one. So when we know whether the configuration of a chiral center is R or S, so by knowing the configuration of that given compound R or S of that stereoisomer, for which you are also know about the sign of its specific rotation or observed rotation, then you know the absolute configuration of that center. So by knowing the R or S configuration, along with it, you should know about the sign of a specific or observed rotation. That means it is dextrorotatory or levorotatory. That then it is absolute configuration. If we know absolute configuration for a chiral center in one stereoisomer, then we know them for the corresponding center in its another enantiomer. So enantiomers, one enantiomer should have absolute configuration, then another one, because as it is opposite mirror images, then we should know about the configuration. We can determine the absolute configuration of another enantiomer. And since they have opposite relative configuration at each chiral center, so that two enantiomers, they have opposite relation configuration at each chiral centers of that two enantiomers. If you are given each of a definite enantiomers in a separate unlabeled bottle with no additional information, you should not know which one is R and which one is S. They have because identical properties except the direction of rotation of plane polarized light. Because of this difference in light rotation, you can determine which is plus and which is minus. Without knowing, you cannot say which is R and which has the S configuration. This means that you do not know the absolute configuration. So if you are not supplied any information, you cannot say without any prior information that which is R and which is S. You cannot know about the sign of its specific rotation, that is means which is plus and which is minus. So you cannot know about the absolute configuration. And that absolute configuration of a stereoisomer with a known specific rotation, you must be able to specify the R or S configuration at each of the chiral centers. So absolute configuration for chiral centers were unknown until 1951. Use of X-ray diffraction to determine the stereoisomer. So before that, absolute configuration was totally unknown to us. Afterwards, there was a study, that means X-ray diffraction method was that study by which we could determine the absolute configuration. But before that, all the configurations were relative configuration. These X-ray diffraction experiments provided absolute configuration for chiral centers in other molecules whose relative configurations were known with respect to the chiral center in the experimental compounds. So if we know about the configuration, but in relation, we know about the relative configuration of any two compounds, then with respect to another one, we can also determine the absolute configuration of any one compound. The precise arrangement of substituents at a stereogenic center is known as the absolute configuration of the molecule. Along with it, the absolute configuration at a chiral center in a molecule is a time-independent and unambiguous symbolic description of the spatial arrangement of ligands bonded to the chiral center. For example, the arrangement of the ligands around the chiral center for case 1 and for case 2 exactly opposite. Chiral centers in 1 and 2, they have opposite absolute configuration as their exactly opposite, and they're also mirror images to each other. So they have opposite absolute configuration. Since the two members of enantiomeric pair are mirror images, each chiral center in one enantiomer must have a configuration opposite to that of the corresponding chiral center in the other enantiomer, right? So the corresponding chiral centers in the two enantiomers have opposite relative configuration. So enantiomer 1 and enantiomer 2, 1 plus and 1 minus. So they have opposite relative configuration. Relative configuration compares the arrangement of atoms in space of one compound with those of the other. So there is a comparison between the arrangement of atoms in space, right? And until the 1950s, all configurations were relative configuration. And before that, all configurations were little bit unknown about the absolute configuration. Afterwards, X-ray diffraction method study was used to determine the absolute configuration. The absolute configuration is the precise arrangement of atom and space, and we can now determine the absolute configuration of almost all the compounds. So now we can know very easily about the R or S configuration, and along with it also the sign of the specific or observed rotation. So now it is very easy to know about the absolute configuration of any compound to you. The absolute configuration of a chiral atom is known when it can be assigned as R or S in pair of stereoisomers. So as you know about the configuration, it is R or S. So we can determine the absolute configuration by knowing the specific rotation, the sign of specific rotation or observed rotation. It is the relative configuration which is experimentally determined relationship between two enantiomers, even though we may not know about the absolute configuration of that compound. So there is a relation between the configuration. If we don't know about the absolute configuration, we can determine the relationship by experimentally of that two enantiomers. Until 1950s, the absolute configuration of no optically active compound was known. That time, only the relative configurations were determined. Instead, configurations were assigned relative to a standard. One standard was maintained. One standard was determined, and it was that glyceraldehyde, which originally was chosen by Emil Fischer for the purpose of correlating the configuration of carbohydrate. So when he was studying with carbohydrate, so he found out the relationship between the glyceraldehyde and carbohydrate to know about the configuration of the carbohydrate. So Fischer arbitrarily assigned the configuration of dextrorotatory glyceraldehyde, which was known as D-glyceraldehyde. The liborotatory enantiomer is designated as L-glyceraldehyde. So in D-glyceraldehyde, the OH just behind the CH2OH attached carbon, that OH is at right hand side, so it was D plus glyceraldehyde, and this OH was left hand side, so it is called liborotatory or minus. So it will be D plus glyceraldehyde and it will be L minus glyceraldehyde. Now absolute configuration is a special arrangement in a chiral molecule, and we can determine the absolute configuration through crystallography, which is X-ray crystallography or X-ray diffraction method. General problem was there that X-rays cannot distinguish between enantiomers, but we could not determine or differentiate the enantiomers by X-ray diffraction method. For new solution was by Isobet method, which was anomalous X-ray scattering. By that way, we determine the configuration of the enantiomers. In this context, relative configuration or configuration with respect to another stereogenic compound, another stereogenic center, another stereogenic element. So there is a relation in comparison with other one, we would determine the relative configuration. So here, for example, here it is an alkene by reaction in presence of palladium. There is a hydrogenation. So no bonds are made or broken at the chiral center carbon in this experiment. So here is a chiral center and here is a chiral center where there is no change, no breaking or making of bond. Both have same sign of rotation, and the arrangement of atoms in space at the chiral atom is analogous. So they have the same relative configuration, right? So no bond, no no bond is breaking, no bond is making, but the specific rotation sign is same and they have the same relative configuration. Here it is rotation is plus, here it is also the rotation is plus. But by this example you can see not all the compounds that have the same relative configuration have the same sign of rotation. It has the rotation minus and it has the rotation plus. No bonds are made, no bonds are broken at the chiral carbon. So here no bond is making, no bond is breaking over this two chiral centers. So relative position of the atoms are the same also over here. See all the compounds, left hand side, right hand side, below are the same. Only the difference is that bromine is substituted with respect to that OH. But the sign of the rotation can change. Here it is minus and here it is plus. So relative configuration can be established by chemical means through reaction in which the configuration at the chiral center of interest is either unchanged or is inverted stereospecifically. So we would go for the chemical reactions where there should be maybe inversion of configuration or it may not be. By reaction we will determine the relative configuration with respect to another given compound. So relative configuration is the position of atoms of groups in space in relation to something else in the molecule compared with absolute configuration which is independent of atoms or groups elsewhere in the molecule. So in relative configuration there is a relation, but in absolute configuration it is independent. Here for example, relative to the position of the methyl group, the chlorine atom is at the same side of the cyclohexane ring. So chlorine and CH3 are at the same side with respect to each other. And the stereo center bearing the chlorine atom has an R absolute configuration. So this configuration, this carbon center is R. And this configuration does not involve or depend on position elsewhere in the molecule. Hence, this molecule is cis-1-chloro-2-methyl cyclohexane, and we may also call this 1R2S1-chloro-2-methyl cyclohexane. So, mind it, the absolute configuration is independent of any other criterion, but relative configuration between the chlorine and CH3, it is related to each other as they are at the same side with respect to the cyclohexane ring. So there is a relation between them. So this is relative configuration. But this carbon center, this chiral center bearing the chlorine, it is absolute configuration and it is R. Same in cis-2-pentene, the methyl and ethyl group are at the same side of this double bond, and the groups with highest CIP rule, group parity, are at highest according to the CIP rule and at the same phase of the double bond. So this is also Z2-pentene. So C strands, E and Z are all designations of relative configuration. So these are in relation, in a relationship, and as along with it together at the same side. So this is cis and it is a relative configuration. By example, diglyceraldehyde and D-glucose at the stereocenter next to CH2OH carbon. So this carbon and this carbon, the OH, both the OH are at the right hand side, so they have the same relative configuration. So diglyceraldehyde and D-glucose, they have same relative configuration. This relative configuration is indicated with the prefix D. D and L are designations of relative configuration. So if this OH is at left hand side and if this OH should be at left hand side, then it was L, and they are also relative configuration. So the arrangement of atoms in an optically active molecule based on a chemical interconversion from or to a known compound is a relative configuration. Relative because there is no way of knowing just by looking at a structure whether the assignment is plus or minus, is correlated to a particular isomer R or S. So by unknowing the specific rotation, the sign of specific rotation and RRS, we could not determine the configuration. We cannot know about the configuration directly. So we can go by any chemical reaction so that we can determine the configuration. So here you can see the structure, see the reaction where the OH is substituted by OTS, tosylate, by reaction in condition is tosyl chloride in pyridine, where there is a retention of configuration and group priority of the stereogenetic center has not been altered. So at the same side and at the same priority, this OH and OTS are there, and which is no inversion, it is retention of configuration. But here when KCN in ethanol was used, the configuration is altered and it is inversion of configuration. So this configuration of starting parent element is R, medium element is R, but the last product is ACE. So the absolute configuration of the parent is known while only the relative configuration of this tosylate and the nitrile are known. So when the relative configuration between them we can know, we can also determine the absolute configuration of the parent compound. See the references I have used. So thank you for this day.